So tonight, because it's Thursday, we're going to do some paper one stuff. So what I wanted to do was
Co-host, please.
oh,
Sorry.
sorry. I thought I'd done that. I beg your pardon. Sorry,
No,
Yolanda.
it's fine.
I beg your sorry. Thank you. Yeah, just as well you remind me before I start talking. Okay, there we go.
Thank
All
you.
right, all sorted. Okay, let's go. So we're going to do the cubic function this evening. I have found some sort of slightly more difficult questions for us to look at as always. So let's crack on and get started on these. How many people do we have with us this evening? Oh, just 19 of us. Okay, well, that's cozy. So
Yeah.
make the most of the opportunity, guys. If you were shy to ask questions before, don't be shy now. No one's going to judge you. We're here to help. We're not here to judge you. All right, we're here to help you prepare for those final exams. So please do ask. Remember, Yolanda is also here to support you as well. Okay, it's not just me. You've also got her help as well. Okay, all right. So question 9, they don't give us much. They just say to us, given f of x equals 3x cubed. So this was 1 year in finals where they decided to ask the cubic function a little bit differently. They didn't ask all the usual questions. So, you know, where is it concave up or where is it concave down, or calculate the coordinates at the turning points, blah, 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 which is the stuff that they usually do. This year, they decided to be a little bit mean to everybody. So that's why it's a nice sort of more difficult question for us. So now they tell us to solve for f of x if f of x equals f prime x. So what does that mean? What do they want us to do with this information? What do they mean by f of x equals f prime x? Can anybody tell me? What does f prime x represent? How would we get f prime x? Ah, there we go. So the cubic function is equal to the graph of the first derivative. Beautiful. Okay, exactly that. So let's work out what the first derivative would be. So if f of x is equal to 3x cubed, it means that f prime x, if somebody can please tell me this, would be equal to what? If f of x is equal to 3x cubed, then f prime x is equal to, there we go, Michelle, well done. It's equal to 9x squared. Fabulous. Okay, so that means that 3x cubed is equal to 9x squared. Lovely, beautiful. Thank you, Ayola and Chloe, for your answers. Awesome. So now what do we do? Because now we've got to start with the mechanics of actually solving for x. So how are we going to do that? What would we do? What should I do with the two terms that are on either side of the equal sign? Hint, 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 hint. So I've done that. Cool. Okay. Okay, Sinatanta, I've got that. I've got them equal. Now what am I going to do with them? After I've equated them, what am I going to do? That's it. Beautiful, Sinantlantla. I could not have said it better. Thank you. Then take the 1 to the other side and make it equal to 0. Absolutely. So this is cubic. Okay, so there have to be 3 possible solutions for x. So when there's more than one possible solution for x, I've got to collect all my terms on one side, and then I've got to factorize. Okay, so I've got 3x cubed minus 9x squared is equal to 0. Okay, so now what am I going to do? I've said it. What am I going to do now? So Iola says, factorize is correct. Iola says, take out 3x squared as a common factor. Absolutely. Factorize. Quite right. We're going to do that. Okay, so we've got a couple of options here. We could divide through by 3 if we wanted. All right, but we would still, in fact, let's do that. So we would have x cubed minus 3x squared equals 0. We could take the 3 out, but we'd still have to divide by 3 through. What we can do now is we can take out x squared. So that would leave us with x minus 3 equals 0. Okay, so based off of this, sorry, I'm going to write back up here again. You would obviously continue underneath. Either x squared equals 0, in which case x is equal to 0, or x would be equal to 3. So we have two solutions. Okay, when we make 3x cubed equal to 9x squared. Either x is equal to 0 or x is equal to 3. Okay, so 3 marks here. There would have to be a mark for our derivative, on our factors, and then on both our answers, like so. Okay, now some knowledge questions. So that was a routine procedures. Now we're going to do some knowledge questions. So now they tell us that the graphs of f prime, and f double prime all pass through the points 0 and 0. What do the graphs of f prime, or of f prime, and f double prime represent? What graphs are these? So f is the graph of the f is the graph of the cubic function. F prime is the graph of the, good. F prime is the graph of the, yes, it's quadratic, Trish. It's the graph of the first derivative. And f double prime is the graph of the second derivative, okay, which happens to be linear. Okay, so we've got the graph of f, our original cubic function, and then we've got the graph of our first derivative and our graph of our second derivative, and they all pass through the origin. For which of the graphs will 0, 0 be a stationary point? You guys tell me. For which of these graphs is 0 and 0 a stationary point? It's going to be the graph of, does a linear function have a stationary point? In true. So a linear graph, a straight line graph, does not have any turning points because it's a straight line, right? So it's going to be the graph of f and f prime, the first derivative and our original cubic. Okay, so the original cubic function and the first derivative. Now 9.2.2. Explain the difference, if any, in the stationary points referred to in question 9.2.1. So if you think about your graph of 3x cubed, what does it look like? What does the graph of 3x cubed look like? Can anybody tell me without me telling you? All right, so we've obviously been out of practice for a little while. Okay, all right, so nobody said the correct answer first. So your cubic function would do something like that. So this point over here is going to be a stationary point that is also a point of inflection. Right, so that's going to be the graph of f. All right, your parabola, sorry, it's a bit wonky on the left-hand side there, is going to look like that. That would be the graph of your first derivative. Okay, so the difference, if any, in the stationary points referred to in 9.2.1 for f, right, it's going to be a point of inflection. Your stationary point is also a point of inflection. The graph of f prime, okay, the stationary point is not a point of inflection because it does not have a point of inflection. For f, there is no point of inflection. Okay, so these are difficult knowledge questions. We really need to understand the graphs of the cubic, the first derivative and the second derivative if we want to be able to answer this. Yes, and Nhlanhla, I see your hand is up. Go for it.
Hi, ma'am.
Hi, Nhlanhla.
Ma'am, I wanted to ask, why would you not call it the turning point or like the minimum point of the derivative, if that makes sense? Like, I get that you called it a point of inflection, but then why can you not call it the turning point for the quadratic?
It is the turning point for the quadratic. It is the
Okay, so
turning
if I
point
had
for the
to
quadratic.
explain it, okay.
Yeah, no, you're absolutely right. Okay, so that point 0 and 0 is the minimum of the first derivative. It is the turning point of the first derivative. All of those things are true.
Okay.
What they are asking though is that when they refer to the word stationary point, that means a turning point. So a stationary
Yes.
point is a turning point. That is where the gradient is going to be equal to 0 because the graph is changing direction.
Yes.
All right. But additionally, for the graph of the cubic function, it is also going to be a point of inflection. So where the graph changes concavity from being concave up to being concave down, whereas your graph of your first derivative is only concave up. It's never going to be concave down. That's what they want from you.
Okay.
Okay, does that make sense?
Yes, it did. Thank you.
Cool. All right, it's a pleasure. Okay, so a difficult knowledge question coming through there for us to answer. Okay, so any other questions apart from what Nhlanhla was asking? Are we all good? All right, let's go and do question 9.3. So this was 9.2 over here. If you do want to ask, please don't be shy. All right, in 9.3, determine the vertical distance between the graphs of f prime and f double prime at x equals 1. So how do you determine the vertical distance between any two functions on the Cartesian plane? How do you determine a vertical distance? That's it, Lesejo. Okay, so it's the y at the top minus the y at the bottom. Okay, yes, so it's the difference between the y values. Perfect. And they've given us the x value at which this occurs. All right. So now, do we know what the equation of the second derivative is? No, but we can calculate it because we've got the equation of the cubic and the first derivative. Remember, our first derivative was 9x squared. So what's the equation of the second derivative, Matrix? What's the equation of the second derivative? That's it. F double prime x equals 18x. Good. Mozi and Ayola have sent Ansihau. Brilliant. Okay, so it's equal to 18x. Okay, so now what we can do is we can sub in our 1. So that would give us 18 times 1. So we would end up with 18. For our first derivative, we also want to sub in 1. Remember, its equation was 9x squared. We've got that up here where you can see my mouse. I don't know, can you see my mouse on the screen? I've never actually asked that before. Okay, but it's here. Let me just...
The mouse on the screen, yes.
Can you see the mouse? Oh, you can see the mouse.
Yeah.
All right. Okay, so you can see the mouse. Okay, I wasn't sure whether you could see that or not. Okay, so we've got f prime x up at the top here. So now again, if we go and we sub in 1, we would have 9 times 1 squared. So that would give us 9. So now we can work out the difference. Okay, so we would work out the vertical difference. Therefore, the vertical distance is going to be 18 minus 9, which gives us 9 units. Okay. All right, and now for the last question. Any questions before I go on to 9.4? Okay, so it would be the y at the top minus the y at the bottom. So take the bigger number and subtract the smaller one. Okay, so your y values get bigger as you go up to the top. Okay, so it would be 18 minus 9, not 9 minus 18. 18 is positive and 9 is positive. So 18 is above 9 on the y-axis. Does that make sense, Jamie? Sure. Okay. Also, distance is a positive quantity. So yeah, that would be the other thing. All right. It's a scalar, not a vector. But I mean, this is not science, but anyway. Okay. All right. So 9.4. Now they ask us, for which values or value or values of x is f of x minus f prime x smaller than 0? What do we need to do here? It's out of 4. So that suggests to us that it's not just reading off information anyway. I mean, we don't have a graph to read anything off, but they are suggesting to us by the mark allocation that they want an algebraic solution. So if they want an algebraic solution, actually, do they want an algebraic solution? We would go and we would substitute in f of x, which would be 3x cubed, and f prime x, which would be 9x squared. The other way that we could look at this is if we took the 9x squared over to the other side, this would be where 3x cubed was smaller than 9x squared. Sorry, I'm just looking at the graphs in 9.2. So where is the cubic function above the parabola? Okay. I think what we should do is stick with what we've got here initially. And I think we're going to do the same thing that we did before, where we divide through by 3, and that will give us x cubed minus 3x squared. Let's factorize and take out our x squared, and in brackets we've got our x minus 3 is smaller than 0. Yes, this is definitely what we want to do. We don't want to take that over to the other side. It's not going to help us unless, of course, we were looking at a graph, which they didn't ask us to draw. Now what we can do is do our answer based on a particular idea, all right? First of all, is it possible for anything that's squared to be negative? Is it possible for x squared to be smaller than 0 is basically what I'm asking you. So can x squared be smaller than 0? Is that possible? No, because it doesn't matter what value I take, whether it's a negative number or a positive number, once I square it, it's going to become positive. So x squared cannot be smaller than 0. Okay, so x squared is always positive. Okay, it's not possible for x squared to be smaller than 0. So what we would need to look at here is the only thing that we can, because in other words, what we're doing is we're taking something that is always going to be positive. Remember, we're multiplying these two together because they're factors. So we're taking something that's positive and we're multiplying it by something else. All right, another thing, in this case, x minus 3. And we want an answer that is smaller than 0. So in other words, we want an answer that is negative. So what does this thing in the bracket have to be? Does it have to be positive or does it have to be negative? Okay, it has to be negative. So that means that x minus 3 has to be smaller than 0. It has to be negative. All right, in other words, x, I'm going to take the 3 over to the other side, is got to be smaller than 3. Okay, so as long as x is smaller than 3, f of x minus f prime x will be smaller than 0. Any questions? You guys are very quiet. Are you okay?
Yeah, we have the untalkative.
A quiet bunch tonight.
Yeah.
Okay. All good. All right. Well, that's good to know. What I didn't show you guys was the answers or where the ticks would be for 9.3. All right. So obviously there would have to be a tick on our answer. I imagine that there would have to be a mark on the first derivative and on our second derivative. For this, subbing in factors, interpreting this correctly, because x squared is always going to be positive, and then here on our answer. Okay. All right. So that was one year when they were really, really mean about the cubic function, and they asked a bunch of questions that were all a little bit different and a little bit more difficult, not the usual story. Okay, let's go and have a look at another question that's also a little bit unusual. Let's just make this a little bit bigger for you guys. And in question 9.2, they give us the graph of G. They tell us that it is a cubic function. And then they give us some important information about G. First of all, they tell us that G of 3 equals G prime 3 equals 0. What does that mean? So G of 3 is G prime 3 equals 0. What does that mean? Okay, yes, Mosey, that's true, but there's a little bit more that I need from you. They intersected x equals 3. No, it doesn't mean they intersected x equals 3. What does G prime mean? Means gradient. So in other words, the gradient when x is 3 is 0. What are they trying to give you there? Are they giving you an x-intercept? Are they giving you a turning point? What are they telling you? Can anybody tell me? Are you guys just all exhausted from school and writing exams? All right, so if they're telling us that G prime 3 is equal to 0, they're telling us that the gradient is 0 when x is 3. So this is information about a turning point. Okay, your gradient is equal to 0 at the turning points of your cubic function. Okay, so this is information about a turning point. All right, so I'll just write here for you, the gradient equals 0 when x equals 3. Okay, this bit over here is telling us when x is 3, y is 0. Okay, so when x is equal to 3, y is equal to 0. What does that mean? That's the easier part, I suppose. What does this bit mean? When x is 3, y is equal to 0. That's an x-intercept. Beautiful. Okay, so this is an x-intercept. So we've got an x-intercept that is also a turning point. Does that make sense to everybody? This is an x-intercept that is also a turning point. So it's an x-intercept that is also a turning point. Makes sense. Okay, cool. All right. Let's look at the next piece of information. All right. So the next piece of information that they give us is that g of 0 equals 27. So here they are telling us when x is 0, y is 27. What does that mean? It's a y-intercept. Beautiful. So that is a y-intercept. Okay, so this over here is a y-intercept. Now they give us a third piece of information, and they want us to use this to get the shape of the graph. Because what we know is we've got a cubic function. What we don't know at this point is whether it is concave up and then concave down, or whether it is concave down and then concave up. So we don't know the shape of our function. So this piece of information is going to help us get that right. We know its x-intercept. We know where its turning point is. We know where its y-intercept is, but we don't know the shape of this function. So now they tell us when g double prime x is greater than 0, when x is smaller than 3. So what does g double prime greater than 0 mean? Does anybody know? What are they referring to here? G prime x is gradient. What does g double prime x mean? What's positive, Iola? That's it, Jamie. Okay, so your concavity is positive. This means your concavity is positive. Let me just go down a little bit. Okay, your concavity is positive. Concavity is positive. So that means that it is concave up when x is smaller than 3. So in other words, if this is, say, 3 over here, smaller than 3 will be everything to the left of the blue dot. So to the left of the blue dot, the graph is concave up. All right. To the right of the blue dot, okay, where x is greater than 3, g double prime x is smaller than 0. So if g double prime x is smaller than 0, that means where the graph is concave down. Concavity is negative. So g double prime x smaller than 0 means concavity is negative. So another way of saying that means that it is concave down. Okay, and this is when x is greater than 3. So everything to the right of the blue dot is where x is greater than 3. So this tells us the shape of our graph, because the blue dot that is a x-intercept is also the turning point, And based off of this information over here about the graph being concave up and concave down, it is also a point of inflection. So we have a turning point that is also a point of inflection and an x-intercept. So the graph would have a really weird shape. It would look something like that. And that bit over there is going to be 27, and that bit over there is going to be 3. All right, so they've asked us to draw a sketch of this graph indicating all relevant points. Okay, so we have to show the coordinates at turning points and intercepts with axes. All right, so 3 is a turning point, a point of inflection, and a turning point, point of inflection, and an x-intercept. Everybody happy with that? So accuracy on our shape, accuracy on x equals 3 is an x-intercept. It is also a turning point, and it is also a point of inflection. All right, and then an accuracy on our y-intercept. Okay, so in other words, that y is equal to 27. Okay, does that make sense? Cool. Thanks, Mosey. Thanks, Iola. Perfect. All right. Yes. All righty. Cool. Okay. So here is is that okay? I can move on to the next question. We're all happy, hopefully. Lesedi, cubic functions don't necessarily have to have 3 x-intercepts. They have to have at least 1, but they can have a maximum of 3. So a cubic function that is shaped like, let's do that, could have 3 x-intercepts if the x-axis was over there. Then it would have 1, 2, 3 x-intercepts. But if your x-axis was over here, then it would have 2 x-intercepts. If your x-axis was up here, it would have 1 x-intercept. Okay, so it depends on where the graph is on the Cartesian plane. Okay, it has to have 1 x-intercept, minimum of 1, maximum of 3. Are you happy with that, Lesedi? No, it only has 2 because it has a turning point. So over here there would be 2. Over here there would be 3. Over here there would be 1. Mache?
Hi, ma'am.
Hi, Mache.
I was wondering, when you work out like quadratic equations, and then you get the x values, which ones do you know is like not applicable?
Are you talking about when you solve a cubic equation?
Yeah, just like solving for x in general. And then there's always like an answer that's not applicable. So how do you know which one of the x values isn't applicable?
Okay, so when you're talking about solving a quadratic equation and an x value won't be applicable, it can come from one of two different things. First of all, if you were solving under a specific condition, so let's say they told you that x was positive, then you would say that any x value that you got that was negative wouldn't be applicable because that's the restriction that was placed in the question. All right, so it could come from a restriction in the question. The other place where you would have to go back and go and check in quadratics, which is what you specifically mentioned, is when you were squaring both sides. So then you have to go back because you've squared both sides. So it would be an equation that has a root in it. So if you were squaring both sides, by squaring both sides, that is when you may have introduced a root that may not be valid. Okay, so it would either be, as I say, as a restriction that was given to you, or in the case of squaring both sides, then you would also go back and check. Okay.
Okay, ma'am.
All
Thank
right.
you.
No problem. Okay. Let's get started on the next question. I don't know if we'll manage to get everything done by the time, I nearly said by the time the bell goes, by the time 7 o'clock rolls around, but let's go ahead and go and do this. Now, I chose this question because it's obviously different from the others, but it's also question 9.1.1 is something that learners generally struggle with. Okay. And this question is about finding the equation of a cubic function. All right, so let's look at the information. They've told us the graph of g of x equals x cubed plus bx squared plus cx plus d is sketched below. The graph of g intersects the x-axis at -5 and at p, so that's this point over here, and the y-axis at 20, we can see the y-intercept. P and R are turning points of G. Okay, so this graph, can you see, I think it was Lasedi, can you see that this graph is like this situation over here where I've put the 2? Okay, it has 2 x-intercepts because it has its turning point on the x-axis. Now, again, this comes from stuff that your teacher would have taught you in class. We'll talk a little bit more about the form the equation is going to take now. What I want to point out to you before we get started is, can you see they have told us something about the shape of the graph? All right, they've told us that in front of the x cubed, there's a +1. That means the shape of the graph, it's concave down and then concave up. All right, so we're seeing what we would expect to see over here. Remember, the sign of the number in front of the x cubed determines whether the graph is concave down and then concave up, or concave up and then concave down. All right. The letter D represents something entirely different. What does the letter D represent? Can anybody tell me? What does the letter D represent? Shame you guys are just exhausted. Okay. The y-intercept, beautiful. Absolutely. So do we know what the value of D is? Do we know the value of the y-intercept? Yeah, it's 20. Absolutely. Okay, so we know that D is equal to 20 because they've told us that that is where the graph intersects the y-axis. So based off of this information over here, we can say that D has to be equal to 20. So this is what we've got so far. We've got g of x equals +1 x cubed plus bx squared plus cx plus 20. Now they've told us what b and c are equal to. They've told us b is 1 and c is -16. Yeah, shame, Swanaka, I can understand that. Okay, I think everybody's exhausted by this stage. Can't believe we've still got another week of school next week. It makes me feel like I want to cry. But anyway, we have to keep going, don't we? All right, so what we're not allowed to do, because the question says show that. So in caps, we are never ever going to verify information. We're always going to prove things. So this means that we can't use b equals 1 or c equals -16. So think about it like this. Zwanaka, if you say your name is Zwanaka. So if I say to you, prove to me that your name is Zwanaka, You can't say to me, you can't answer me by saying, my name is Zwanaka. You have to prove that to me by showing me other information. All right. So in other words, you need to show me your birth certificate or your ID card or your passport. That proves that you are Zwanaka. Okay. So you cannot use what they gave you. Right. We've got to use other information in order to be able to get to the answer. We know what the answers are supposed to be. And the reason that they gave them to us is so that we can answer question 9.1.2 if we can't do question 9.1.1. Yes, Pumi, you are on the right track. Everybody look at what Pumi did, but there's a little bit of a but, Pumi. Okay, but I'm so glad you said that. So Pumi said, well, when these things factorize, don't they factorize into 3 brackets? X minus root 1, x minus root 2, x minus root 3. Yes, what's the but though? The but is, in this case, what we don't have 3 distinct roots. We have, yes, we've got an x-intercept that is also a turning point and another x-intercept. So what happens when a turning point is also an x-intercept, or when an x-intercept is also a turning point? What does that do to our equation? How does it change? We don't have 3 distinct x-intercepts. We square, exactly. So the x-intercept that's also a turning point ends up with a square on it. Quite right. It ends up with a square on it. So what we've got here is g of x equals x minus root 1, x minus root 2, and the bracket x minus root 2 is squared because that point P is an x-intercept and it is a turning point. So let's think about the information that they have given us that we can now go and sub in, now that we've got the equation of the cubic correct. First of all, they've given us a y-intercept. So when y is 20, x is 0. When y is 20, x is 0. Have they given us other information? Yes, they have. Look here, they've given us the other x-intercept. So let's go and sub that in. So we've got 20 equals 0 minus, and now we're going to put in our negative 5. 0 minus, and we don't know what the x-coordinate at P is going to be. So I'm going to call it P for argument's sake. And now what I want to do is solve for that x-intercept, because when I've got that, I can multiply everything out and I can work out I can show what the values of B and C and D are going to be. Now, the other thing that I have left off, which is a little bit naughty of me, sorry, is there should be an A in the front. Okay, but they've told us up here, highlighted in yellow, that this is a 1 that is in front. Okay, so it's not going to make any difference. Okay, but we should never assume that A is equal to 1, but in this case it is given because in front of this x cubed there is an invisible 1. Okay, all right, so now let's multiply out our brackets. Let's just see, P is equal to 2, Mosey says. All right, let's see, Mosey. Okay, so we've got 0 minus 5, sorry, 0 minus negative 5. So that gives us 5. And 0 minus P would be P squared, like so. Divide both sides by 5. So P squared would be equal to 4, because 20 divided by 5 is 4, and therefore P could be equal to positive 2 or negative 2. Which is it going to be? P is going to be equal to, P is a point on the positive x-axis, so therefore P will be equal to 2, like Mosey said. Cool, Mosey, thank you so much. Brilliant. Right, now we are ready. That's it, to go and multiply everything out. So we've got g of x equals, in our one bracket, the invisible one in front, x plus 5 in the one bracket, and in the other bracket, we're going to have x minus 2 squared. Does that make sense to everybody, that I have changed the signs? So we've got our x plus 5. Here we're going to have x squared minus 4x plus 4. Oops, I'm running out of space here. So that gives us x cubed minus 4x squared plus 4x plus 5x squared minus 20x plus 20. Okay, so this is going to be equal to x cubed plus x squared. 4 take away 20 is minus 16x plus 20. All right, so we've shown that B is 1, C is minus 16, and D is 20. It's a little bit long, but there we go. All right, so that would be 9.1.1. Lots of algebra going on there.